There is a picture, sort of artist's impression, before the space age of what Venus might be like on its surface, and so this was looking at the planet Venus. It was science fiction and science fact all the way up to 56 before the start of the space age, but it wasn't completely disproved. This idea of a really sort of lush environment on Venus until 1967, which is when the first measurements in detail were done at Venus. So Mariner 4 and Mariner 5 confirmed the feeling from an earlier space mission that in fact the surface of Venus was not like this at all, but extremely hot, and also that the clouds were made of sulfuric acid, so there wasn't a nice water cycle like is going on in this picture, and so that it had to wait for these in situ measurements by spacecraft to actually do that, and so Venus turned out not to be quite as Earth-like as we thought, and I'll sort of tell you about some of the latest results from Venus Express, which there are some Earth-like features, but to a large extent, it's not like the Earth. Okay, so a brief comparison between
So this is the big benefit of a universal philosophy. It says it applies to everybody. Well, looks that doesn't, 205 or 206 countries in the world. And you've got something that applies to everybody. That's a bit strange, isn't it? No, says liberal theory. There are same value structures that apply to all of us. You couldn't have the United Nations without it. It couldn't tell you that the Universal Declaration of Human Rights without this idea of values that apply to all of us just because we are humans. Now, the idea is to test that as well. Why is sport universal? Why does everybody play football? It's because the values are specified at a very thin level at the top. There are these rules and we all have to abide by just these rules. But there are lots of things about football that aren't rules specified. So Brazilian football is different from Italian football, from British football, from German football, from Spanish football. It's culturally specific, but acknowledges that there are these universal general rules to apply to everybody.
It's rare to find an adult who actively still wonders what their parents think. But that isn't to say that we aren't wondering about our value in more general terms. It's just that we may, without noticing, have taken the question somewhere else, and very often to particularly harsh modern figures of authority, media, and social media. To this pitiless arena, the self-doubting person now directs all their fears of unworthiness and panic desire for reassurance. To a system set up to reward sadism and malice, they constantly raise their phones and implicitly ask, "Do I deserve to exist? Am I okay? Am I beautiful or respectful enough?" And because social media is built on the troubles of the individual soul, the verdict is never a reliable yes. One is never done with cycles of fear and reassurance seeking. Every time their spirits sink, which is often, the self-doubting sufferer picks up their phone and begs to know whether they have permission to go on. If this might be us, we should grow curious about, and jealous of, people who are free. They are so because someone long ago settled the question of what they were worth, and the answer has seemed solid ever since. Social media is a roar in the next valley, not a mob in their own mind. Learning from these calm souls won't just involve deleting a few apps. We will have to go further upstream, back to the baby self, whose alarmed inquiries we must quiet once and for all with ample doses of soothing, and till now, absent kindness.
Take a look outside a window. What is the season where you are? How do you know? Most likely, you looked at a tree or plant and noticed details about its leaves and assessed the qualities of sunlight streaming outside. Observing the timing of biological events in relation to changes in season and climate is called phenology. When you notice the daffodil buds are poking through the snow and think spring is on its way, you're using phenology. When you see leaves turn from green to red, and watch migrating birds fly past, and realize that summer is over, autumn is here, you're using phenology. Literally meaning, the science of appearance, phenology comes from the Greek words, pheno, to show or appear, and logos, to study. Humans have relied on phenology since the time of hunters and gatherers. We've watched changes in seasons to know when to plant and harvest food and when to track migrating animals. Scientists observe and document seasonal changes in nature and look for patterns in the timing of seasonal events. Timing of these natural signs has remained consistent until recently. Increasing global temperature is causing rhythms of nature to shift. Budburst, the day when a tree or plant's leaf or flower buds open, is occurring earlier in the year for some species. For every 1 degree Celsius rise in temperature, budburst happens 5 days earlier than usual. Differences in timing affect not only plants, but the insects and birds that depend on the plants for food.
Carbon dioxide, or CO2, is the main greenhouse gas in climate change. So how does CO2 get into our atmosphere? Well, carbon is part of a cycle. It starts with the sun, which heats the Earth's surface with more energy in 1 hour than the whole world uses in a year. Plants, which are kind of like biological chefs, take that sunlight, and then suck in some CO2 from the air, mix them together, and bam! They create a stored form of energy, in the form of carbohydrates such as glucose and sucrose. The process is called photosynthesis. When animals like us eat those plants, our stomachs convert that food back into energy for our own growth. Greenhouse gases are a byproduct of this process, and are released through waste. If those plants die, they decompose, and tiny microorganisms break down those carbohydrates and again, release greenhouse gases as a byproduct. As you see, energy originates from the sun. It is then transferred as it moves through the food chain. But sometimes, carbon-based organisms like plants or animals get stuck in the earth. When this happens, they're compressed under tons of pressure, and turned into carbon-based fossil fuels like oil, coal or natural gas.
The major currency of our reward system is dopamine, an important chemical or neurotransmitter. There are many dopamine receptors in the forebrain, but they're not evenly distributed. Certain areas contain dense clusters of receptors, and these dopamine hotspots are a part of our reward system. Drugs like alcohol, nicotine, or heroin send dopamine into overdrive, leading some people to constantly seek that high. In other words, to be addicted. Sugar also causes dopamine to be released, though not as violently as drugs. And sugar is rare among dopamine-inducing foods. Broccoli, for example, has no effect, which probably explains why it's so hard to get kids to eat their veggies. Speaking of healthy foods, let's say you're hungry and decide to eat a balanced meal. You do, and dopamine levels spike in the reward system hotspots. But if you eat that same dish many days in a row, dopamine levels will spike less and less, eventually leveling out. That's because when it comes to food, the brain evolved to pay special attention to new or different tastes.
While a written word might have multiple definitions, we can usually determine its intended meaning through context. In speech, however, a word can take on additional layers of meaning. Tone of voice, the relationship between speakers, and expectations of where a conversation will go can imbue even words that seem like filler with vital information. This is where and come in. Or a and ehm, totoa and eto and ano. Linguists call these filled pauses, which are a kind of hesitation phenomenon. And these seemingly insignificant interruptions are actually quite meaningful in spoken communication. For example, while a silent pause might be interpreted as a sign for others to start speaking, a filled pause can signal that you're not finished yet. Hesitation phenomena can buy time for your speech to catch up with your thoughts, or to fish out the right word for a situation. And they don't just benefit the speaker. A filled pause lets your listeners know an important word is on the way. Linguists have even found that people are more likely to remember a word if it comes after a hesitation. Hesitation phenomena aren't the only parts of speech that take on new meaning during dialogue. Words and phrases such as like, well, or function as discourse markers, ignoring their literal meaning to convey something about the sentence in which they appear. Last week we talked about how people recognize objects and really how well people recognize objects, given how difficult the problem is, given how objects can be seen in all different sorts of illumination, in different positions, in different angles. And yet we are able to extract that information, we are able to take the visual stuff out there, interpret it in a way that allows us to recognize all the different things that we can see in our environment. Today we're gonna kind of carry on looking at that, but we're gonna look at what's really a special class of objects. That's the human face. So we're gonna look at how we recognize human faces and how we do it quite as well as we do. We're really expert at recognizing faces. So again we can think about how do we take that visual information and how do we transform it into a form which allows us to put a name to a face, and to do all the other clever things that we can do with faces. So I'm gonna start off again by just pointing out that it's a hard problem. Face recognition is a hard problem, and it's a clever thing we do. If you think about all the different types of faces you can recognize, and all the different types of information you can get from the face, you kind of start to appreciate how well we can do face recognition. Why can't we transplant brains? First of all, we should look at what the brain actually does. This thing inside our skulls that weighs on average about 3.3 pounds is larger in humans than any other vertebrae when compared to body weight. That's why we are so brainy. The busy brain is our command center for our nervous system, which takes in data from our body and gives directions to our muscles. In fact, it does so much work, it requires about 20% of our energy to run it. When we are brain dead, we no longer have any neurological activity. With the help of machines, we can be kept alive for a short time, but within a week, the body will not be able to function. While we may still be alive in some sense for that week, we are technically dead when the brain is dead. Some good news is that during the time we are kept alive, some of our other organs can be donated. But why can't we accept someone else's brain? When we transplant something such as a heart, surgeons use a mechanical pump to keep blood flooding through the body while the new heart is being put in. The new heart is then connected to the major blood vessels, and this might take several hours. You'll stay in the hospital for 1 to 2 weeks, and if your body doesn't reject its new heart, it's said 87 out of 100 people make it through the year, and 60 out of 100 get through another decade. So, wouldn't it just be possible to open the skull and connect a new brain where the removed brain was connected? This question was asked to a professor of neurosurgery at Yale in 2013. He actually did say that one day this operation might be successful, but right now we are not even close. The reason is because it's just too darn difficult to connect nerve fibers from the new brain to the native spinal cord. This, he said, is why spinal cord injuries can be so devastating. If we could transplant brains, we would likely not have so many people that are disabled due to spinal injuries.
But what exactly happens to your body when you're in a coma? First, we have to be clear that comas are very different from sleep, despite the fact that the origin of the word comes from the Greek for coma or deep sleep. Comas are not sleep, however, and are instead various forms of unconsciousness that render a person unable to respond to any external stimuli. You can play the loudest, heaviest death metal in the world right next to someone who's comatose, and you won't succeed in doing anything except really annoying the neighbors. Likewise, you can even physically hurt people in a coma, and they will remain completely oblivious and unresponsive. In times in the not-too-distant past, this was sometimes used as treatment, with doctors trying to shock their victims back into consciousness. Everything was tried, from exposing parts of the body to open flames, to severely dropping the body's temperature with ice, to even bloodletting from the head directly. One treatment even included wholly emptying the stomach. We guess because the doctors thought that if a patient got hungry enough, the body would force them to wake up. Or maybe they really were just throwing everything, including the kitchen sink, at the problem, which we're sure was also tried. Comas can occur as a result of serious trauma or as a deliberate medical treatment by doctors. They are typically brought on by traumatic head injury, and it's believed that it's the brain's way of shutting down so it can focus on repairing itself. They can also, however, be brought on by a stroke or a brain tumor, drug or alcohol abuse, or an illness such as diabetes or infection. Most of the time, a coma only lasts a few weeks though, but past this period, the patient can enter a persistent vegetative state that severely lessens their chance of ever coming back out of one.